So here's a quick look at the launcher that we're going to be using today to study projectile motion. It's a spring mechanism that's going to launch a steel ball forward in this direction to the right. You can see the ball's in there, but it's not loaded. I have to cock the spring. There's a trigger mechanism that you release by pulling on that lever. And if you look at this side, you can see it pivots around the launch position. You can angle it upward and fix the angle. And when you do, the protractor on this side reads the deviation from horizontal. So I just tilted it upwards, looks like about 34 degrees. And then I can fix the angle by tightening that bolt on the back. So looking at the lab diagram, we're going to launch the ball here at an angle theta from horizontal, and it will move outward with some initial velocity, but at the same time begin free fall. And depending on how much vertical and horizontal velocity it has when it launches, it will eventually fall through some height h to hit the floor over here, and during that time it will travel a distance r. So we need to be able to measure h and r in this setup. I just showed you the measurement of theta. Once we know all those, we can kind of put everything together. So to find h, the height that the ball is going to drop through the air after launch, you can see the launch position is marked on the side of the tube here, and the ball's going to travel far enough down until basically it's going to travel down until the bottom of the ball hits the ground. So the h that we need to measure is the distance from the bottom of the launch position to the floor. So you can see one thing I've done here is set up a plumb bob that's hanging down. And you can see there's a little post-it note there, the edge of which is marking the launch position. So I'm going to use that for the distance measurements, but for now, to get the height of the launch position, if we hold up a 2-meter stick with the edge on the ground and line it up here, I'm going to try and line it up so that it's pretty close to parallel with the plumb bob. And you can see we're right about 103 centimeters from the ground, just as a rough measurement. But as we talked about in the measurement lab, this is what the end of the meter stick looks like, so we don't exactly have a reliable zero here. So what I'm going to do to actually measure this is use my laser distance meter. I'm going to line this up. It measures from the back of the unit. So hold it like this. And I'm going to do a couple of measurements. And we can see there, it's a pretty consistent 1.03 meters from the bottom of the launch position to the floor. So now what's left is to measure r, the distance the ball is going to travel. And to do that, we're using this pretty heavy steel ball, and when we launch it through the air, it'll fall and hit the ground, and if we have a piece of paper on the ground, this ball will leave a very noticeable dent in the paper, and then we can pretty easily measure the distance from below the launch position out to where the dent is on the paper. So I'll go ahead and show you a launch. I've actually just finished recording all the data we're going to use today. So you can see I have all the paper down with the landing positions marked. It's all already been measured, but I went ahead and set it to an angle that I didn't use in the experiment, where I think there's some paper on the ground, just so I can show you the launch process with the dent. So go ahead, and I've got the launcher set at about 62 degrees right now. I'm going to push it through 2 clicks. It has 3 range settings. We used the medium range, which is 2 clicks down the barrel for all the launches today. And just move the camera around so you can see this. I think we should hit that sort of second cluster of paper over there. And we launch this. Okay, yeah. So that's right on the paper there. And you can see there's my nice fresh dent where the ball hit the paper. There's the previous impacts from the data I collected today also. So I'll go ahead and put up the results of those measurements. You can plug them into the analysis and get to work figuring out how fast this thing is coming out of the tube.